Hello viewers, I am Kausalya. Today we are going to solve problem under exercise 8.4. So problem number 5 and the question number is 6. So here we have to prove this given expression. So the expression is root of 1 plus sin A divided by root of 1 minus sin A, which is equal to secant A plus tan A. So here we are taking our LHS part, right? And I am multiplying and dividing this term by 1 plus sin A. So 1 plus sin A divided by 1 plus sin A. So now what happens, you see, when you look at the numerator, both these terms are same, right? So this is just like A into A. So we can write it as A square. So here 1 plus sin A the whole square, and when you look at the denominator, this is of the form A minus B into A plus B, which can be written as A square minus B square. So in the place of A I am having 1 and the place of B I am having sin. Therefore 1 square minus sin square A. Right. So again you see I am keeping this numerator as such, and 1 minus sin square A can be written as cos square A here. Right. So when you take the square root, what happens? This square root and this square cancels, and finally we are getting 1 plus sin A. And similarly root of cos square A means this square and the square root cancels, and here we will be having cos A. Now I am going to split and write this term. So this can be written as 1 by cos A plus sin A by cos A. So 1 by cos A is nothing but it is secant A, and sin A by cos A is tan A. This is what we actually need to prove. Right. Our next problem is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta, which is equal to tan theta. Right. So as a first step, when you observe the numerator, you see we are having sin theta in both these terms, and similarly cos theta in the denominator part. So I am taking sin theta outside from the numerator. So what are all the remaining terms? It will be 1 minus 2 sin square theta. And here when you take this cos theta outside, what happens? Here it is 2 cos square theta minus 1. Right, because we are taking this cos theta outside. So here you see this sin theta into 1 minus 2 sin square theta and divided by cos theta into 2 cos square theta minus 1. So in the next step, I am replacing this 1 by sin square theta plus cos square theta, because sin square theta plus cos square theta is 1. Similarly, again I am replacing this 1 by sin square theta plus cos square theta. Right. Now I am solving. So when you solve, what happens? You see sin square theta minus 2 sin square theta gives you minus sin square theta. And here there is only one cos square theta. So write this cos square theta as such. Right. You see, this is also sin square theta and this is also minus 2 sin square theta. So 1 minus 2 gives you minus 1 sin square theta. This is what written here. Now when you look at the denominator, so cos theta, and here 2 cos square theta minus cos square theta gives you plus cos square theta, and this minus sin square theta remains here as such. Right. So when you compare, both these terms are same, so we can cancel them. And finally here we are having sin theta by cos theta, which is nothing but tan theta, that is equal to your RHS. Right. Now we will move with the next problem. So our 8th problem is sin A plus cosecant A whole square plus cos A plus secant A the whole square is equal to 7 plus tan square A plus cot square A. Right. Again we are taking our LHS part, you see, and here this is of the format A plus B whole square. So A square plus B square plus 2AB. Right. So sin square in the place of A, sin A. So sin square A. This is your A square and this is your B square and this is your 2AB. Right. Similarly, we are going to expand this expression also, again in the format of A plus B. So here it can be written as A square cos square A plus secant square A plus 2 times of cos A into secant A. Right. So here the next step is, you see, we are writing these two terms as such, plus I am replacing this cosecant A can be written as 1 by sin A. right? And similarly here secant A can be written as 1 by cos A, right? The remaining terms we can write it as such. So this sin A get cancels, and finally this cos A get cancels, right? So we are writing the remaining terms, that is sin square A plus cosecant square A plus cos square A plus secant square A plus 2 plus 2, right? So since everything is in addition, I am writing in this way, that is sin square A plus cos square A. So sin square A plus cos square A is nothing but it is our 1, right? And cosecant A can be written as 1 plus cot A. Therefore, cosecant square A is written as 1 plus cot square A, and secant square A is written as 1 plus tan square A, right? So here now I am going to add all the numbers. So 1 plus 1 2, 2 plus 1 3, 3 plus 2 is 5, and 5 plus 2 is 7, right? Therefore 7 plus cot square A plus tan square A. This is the thing what we actually need to prove, right? So this problem is over here. So our ninth part of our problem number 5. So here it is cosecant A minus sin A multiplied by secant A minus cos A is equal to 1 by tan A plus cot A. So here in this case we are going to take both LHS and RHS. So first we are taking this LHS, and cosecant A is written as 1 by sin A and secant A is written as 1 by cos A, right? Now again we are going to take LCM because here we are having a minus sign in between. So when you take LCM, what happens? The denominator term is sin A. So here in order to make this as sin A, you have to multiply both the numerator and denominator by sin A, right? So 1 minus sin A into sin A becomes sin square A divided by sin A, and here cos A into cos A becomes cos square A. So 1 minus cos square A by cos A, right? So 1 minus sin square A can be written as cos square A, and 1 minus cos square A can be written as sin square A. So now here the sin A and the square cancels, and this square and cos A get cancels, and here the answer is cos A into sin A. Okay, this is for our LHS part. Now consider your RHS part. So what is your RHS? It is 1 by tan A plus cot A. So here tan A is written as sin A by cos A, and cot A is written as cos A by sin A. Again we are going to take LCM. So when you take LCM, what happens? This 1 divided by, right? When you take LCM, the denominator term is sin A cos A, and here sin square A and cos square A, right? You know how to take LCM, right? Yeah, here we are having cos A. The additional term is sin A, so we have to multiply and divide by sin A, right? So sin A into sin A becomes sin square A. Similarly here cos A into cos A becomes cos square A. So sin square A plus cos square A becomes 1, right? So when you move this denominator term to the numerator, this appears as a reciprocal. Therefore, this appears as 1 into sin A cos A, which is nothing but sin A cos A. So this LHS term is also equal to cos A sin A, and similarly here this RHS is also equal to sin A cos A, right? So therefore, we had proved this expression. Okay, this expression is quite correct. Now we will move on with our next thing. So the problem is 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan A by 1 minus cot A the whole square, which is equal to tan square A. So here you see we are having 3 terms, right? So first you have to take this term and you have to prove that this term is equal to this tan square A. And the next step you have to take this term and again you have to prove this term is equal to this tan square A, right? So first we are considering this part. So 1 plus tan square A divided by 1 plus cot square A. You see here we want the answer in the form of tan, right? Therefore, I am rewriting this cot in the form of tan. So cot square A becomes 1 by tan square A. So once you take LCM, 1 plus tan square A divided by tan square A, you see 1 into tan square A, right? So tan square A plus 1 by tan square A. So when you write this expression, this denominator term, this appears as a reciprocal here. So here it is 1 plus tan square a into this appear as tan square a by 1 plus tan square a. So here these two terms get cancelled, and finally here we will be having our this tan square a, right? So these two form one term and these two form one term. So these two terms get entirely cancelled. So finally we are having tan square a, right? This is what we need to prove. Now we are considering this part, right? When you consider this part, you see, again I am writing cot in the form of tan, right? So 1 minus tan a divided by 1 minus this cot a is represented as 1 by tan a, the whole square. So the next step is we have to take LCM. So 1 minus tan a the whole divided by tan a minus 1 by tan a the whole square, right? So now the thing is, you see, this numerator part has 1 minus tan a, but here this denominator term has tan a minus 1. So what to do? We have to take minus commonly outside from this term. So when you take minus outside, what becomes? This plus tan a becomes minus tan a, and this minus 1 becomes plus 1. That is, we will be having a term similar to that of the term in the numerator, right? You see, when you take minus outside, what happens? This plus tan a becomes minus tan a, and this minus 1 becomes plus 1, right? So this is what I had actually done here, and you see everything is inside your square, right? So this is the thing which is done here. So 1 minus tan a the whole square, and what happened when the minus is squared? That is minus 1 the whole square. What happens? Minus 1 into minus 1, which is nothing but plus 1. Okay, minus into minus becomes plus. So in the same way, this minus the whole square becomes plus, right? And here I am having this 1 minus tan a the whole square divided by this tan a whole square becomes tan square a, right? Now I am moving this denominator to the numerator part, so this will appear just as a reciprocal, right? So 1 minus tan a whole square multiplied by tan square a by 1 minus tan a the whole square. So now these two terms get cancelled, and finally we are having our tan square a, right? So this is what we actually need to prove, right? Finally, you see, we have made this first term equal to tan square a, and similarly this second term is also equal to tan square a, right? So here comes the end of this video as well as this exercise. If you have any doubt, let me know in the comment section. Thank you.